can look into a closure algorithm. So, set of items of closure I. So, it will return a set of items which is so the closure I is the function. So, we start with a set j, j is initialized to I. So, whatever you have in the item I here, so j will have those items, and then for each item A producing alpha dot B beta in j, and for each production B producing gamma of j. So, if B dot gamma is not in j, then we add B dot gamma to j. So, this algorithm we have already intuitively seen, like while discussing on the examples. So, this is a formal way of writing the algorithm. So, until no more items can be added to j on one round. So, if you try with all the rules and then find that no more production can be added, then we will be stopping the algorithm and it will be returning the set of items j. So, that is the closure algorithm. Similarly, the go to algorithm. So, this also we have seen the go to operation. So, this is very simple. So, go to I x from item I on input on the input x, where do you go. So, input may be a terminal or a non terminal or basically some grammar symbol. So, it starts with j equal to empty, and this if A producing alpha dot x beta is in I, then we add closure of A producing alpha x dot beta to j. So, this is alpha dot x beta is in I. So, on x it will go to alpha x dot beta, and then we take the closure of it and then add that item to j. So, it will be returning j. So, this is the go to part. Now, the algorithm for constructing the LR0 items. So, we start with the augmented grammar g dash, then this is the grammar is passed. So, we start with the initial set, which is the closure of this particular rule s dash producing dot s. So, this, as you remember, that this s dash producing dot s is the additional rule that has been put into the set into the grammar g to get the augmented grammar g dash. So, c equal to closure of s dash producing dot s. Now, for each set of items I in C and for each grammar symbol x, so if go to I x is not empty and not in C, then we add go to I x to C. So, we have already seen how to make this go to I x function and the closure function. So, if it is if it can give us some new item, then we will be adding it to C until no new set of items can be added to C on a round. So, this way it will be constructing the LR0 items. So, this is simply the procedure. Okay. Now, once we have done that, so let us take an example of grammar and how these items can be constructed. So, this is the grammar E dash producing E. So, this is the original ETF grammar augmented with the rule E dash producing E, and the initial item is constructed by closure of E dash producing dot E, this item. So, this E dash producing dot E will have E dash producing dot E. So, this we have already discussed. So, wherever you have got dot before E, so all these rules will survive E dash E producing dot E plus T and E producing dot T. From E producing dot T, so this rule will come T producing dot T star F and all. Now, from this, so we take the go tos. So, you look into the symbol that comes after dot. So, after dot we have got E, T, F, open parenthesis and I D. So, for each of these cases, so I have to find what is the corresponding go to. So, if I do it on E, so I will get E dash producing E dot and E producing dot E plus T. So, that is there. Then you have got this thing T. So, if you get T, then this E producing T dot and T producing T dot star F, they will come. From ID, I will get I will get F producing ID dot, and from this open parenthesis I will get F producing dot E, and since dot E is coming, so all the rules will come. So, E producing dot E plus T, then E producing dot T, then T producing dot T star F. So, all these rules will come. So, this is all these 4 sets that we have considered seen. So, they are all new sets, and also this on F. So, it will go to, so this labeling is missing. So, this should be on F. So, this is on F, it comes to the state 3 I 3. So, this is E producing T producing F dot, because nothing more has to be done. So, it is like this. Now, from this one, from I1 you see that I have got a dot before plus. So, on plus it will go to the state E producing E plus dot t, and from this E plus dot t. So, this dot is there before t. So, again all these rules will come, T producing dot T star F, T producing dot F, F producing with dot within bracket E and all that. So, all of them will come, and from this one there is a dot before star. So, based on that it will come to this rule T producing star dot F, and then since there is a dot before F. So, it will be all these F rules will come, F producing dot E dot within bracket E and F producing dot I D, like that. Similarly, from this I cannot have any more production, because this is there is not no symbol after this dot. From for this one I will get this dot E. So, dot E it will be adding this thing. So, dot E will be so on E it will go to dot E plus dot T, and this F producing E dot within bracket E dot, like that. And so, from this one I will have also rules like on T, on T it will go to E producing T dot. So, it will have E producing T dot and T producing T dot star F. So, these two will come, and that will give me the rule I 2 only, the set of items I 2 only. So, that does not give us any new set of item. Similarly, on F within bracket. So, from this state if we try to take a transition on F producing, so on this go to I 4 open parenthesis, then it will give me this rule F producing open parenthesis dot E close parenthesis. Now, since so this is same as I 4, because I 4 was like that only. So, this will be giving us I 4 only. So, if you try to draw explicitly, then you can draw this type of transitions. So, like this. So, this is on open parenthesis. Similarly, this is on T, this is on T. So, like that you can draw other cases. Okay. So, this is not, they are not shown here. So, apart if you explore this algorithm, you will find that excepting these set of items, no new items are generated. So, all others are just duplicate of the previous ones. So, that way you can just write down the set of items that are generated from the grammar rules. Now, so next we will be looking into how to use this LR0 automata for identifying the strings. So, initially the stack contains the state 0, and this the symbol is dollar and input is ID star ID dollar. Then it will say that it is getting this ID. So, it will be shifting to state 5. So, how does it shift? So, that decision we will see later. Suppose we can, the action is like shift the next input and go to state 5. So, it shifts the next input ID into the stack and go to state 5. So, this 5 state is put into the stack. Now, it says that now the next input is ID and the star, and the current state is 5. So, current state is 5 and the input is star. So, it finds that there is a rule like F producing ID dot. So, based on that it understands that it has seen a handle. So, it will reduce this by F producing ID. So, this ID will be taken out from the stack, and now the new state will be this F will be put into the stack, the left hand side, and the new state will be determined by the go to part. We will see that algorithm. So, it will come to state 3. So, this way this algorithm will proceed and it will finally come to this accept state. I am not going to explain it in detail, because it is not possible to understand it until and unless we have seen in more detail how this parsing algorithm works with the help of this basic set of items and the transition diagrams. So, this is how the input works, this parsing process works. So, we have got this LR parsing algorithm. So, it has got a stack which has got this states in it. So, the stack will have the states. So, initially this is dollar and it has got the other states in it, and then this is the input A1 A2 up to ended with a dollar, and there is a parsing table. So, which has got two parts in it, one part is called action part, another is called go to part. So, this action part and go to part, so these two are there. So, this LR parsing program, so it will take the it will consider the current input, it will consider the so it will consider the current state, the current input, and it will consult the corresponding table, and based on this table it will take some action. Okay. Whether to shift the next input or whether to do a reduction, whether to accept, and accordingly it will output maybe the production rule by which it does the reduction, or the declaration that the input is accepted or error. So, like that. So, that is the output part. So, this is the LR parsing algorithm. So, if let A be the first symbol of the input stream W, repeat now what we do, and let S be the state on the top of the stack. Now, if action of S A is shift T, so the action is shift T, so it will put it will push T onto the stack, and let now let A be the next input symbol. Otherwise, if the action is by reduce A producing beta, so it will pop out beta symbols from the stack, and now if the state T is on the top of the stack, then it will go to it will push go to T A onto the stack and output the production A producing beta, else it will the action is accept, then it will accept it, otherwise it will call a recovery routine. So, what does it mean? If this is the input, so at any point of time, suppose this is the symbol A that we have, and the current state, so that is on the stack, we have got the states, and the current state is say S. Now, it will consult the table, the parsing table for the state S and input A, and if the corresponding input is shift T, so we will represent it normally by S T. So, it will be doing so this part identifies the that it is a shift action. So, it will do a shift operation and the new state will be T. So, in that case what it will do? It will push T onto the stack. So, it will be pushing T. So, this S so T becomes the state on the stack and the input pointer will be advanced to the next one. So, that way this pointer is advanced. On the other hand, if action is reduced by A producing beta, then it will be popping out beta number of entries from the stack, and then it will be if T is on the top of the stack now, then it will be finding out this go to T A this state, and it will be putting it into the stack. So, we will see some example and then it will be more clear. Okay. So, we do not know how do we construct this table, okay. This parsing table, how do we construct, suppose that is not known. So, let us see how this suppose this table is given to us, and the meaning, the way we read this table is say in this state. So, the state 0. So, if you get an input ID, then this is the corresponding action. It says that you do a shift operation. So, input will be shifted and it will be coming to a state 5. Okay. That is how we will read it. Similarly, this is S4, that means if in the current, if the in state 0, if you find open parenthesis, so you will do a shift operation and it will come to state 4. Now, this one, say this reduce, so this one, so R4, it tells that you have to in state 3, if the input is star, if the input is plus, then you have to apply reduction rule number 4 for doing a reduction. So, for that purpose, these grammar rules are numbered like 0, 1, 2, 3, 4 like that. So, it says that you have to apply a grammar rule and do the reduction by that. Okay. So, let us see how this thing proceeds. So, let us take an consider an example, say this is the string. So, ID star ID plus ID. Now, initially my input pointer is here and this stack contains state 0 and there is nothing symbols in the stack. Now, it will be finding, so this is the input ID. So, this will be from state 0 and ID, state 0 ID, it says that it should be state 5. So, 5, the state 5 is pushed into the stack, and then this symbol ID is also put, we have seen the symbol ID. So, this is on the, this is also on the stack. Now, it says the next is star. So, this star is so now state 5 star. So, it says reduce by rule number 6, and rule number 6 is F producing ID. So, it says, so it will do a reduction. So, this ID will be taken out. So, ID will be replaced by F, and the new state will be identified from this. So, to identify the new state, what we will do? For new state, whatever, if T is now the top of the stack, then go to T A will be the new state. So, now after taking it, so 3 is on the top of the stack. So, 3 F. So, 3 F sorry. So, sorry, this 3 is also popped out, because from state 3. So, it has found F. So, we are at this point. So, this is reduced by F producing ID. So, this state 5 has gone out. So, this state 5 has gone out. So, this top of the stack now contains 0, and this 0 F. So, 0 F says that the new state is 3. So, this F is put into the stack, and this 3 is put into the stack. So, F is remembered as symbols, next symbol, and 3 is the stack. Now, the next at state 3 I have got this star. So, state 3 star says that you do go by rule number 7, reduce by rule number reduce by so, this is basically, so this is not rule number 7. So, this is rule number 4, there is a mistake here, this should be rule number 4. So, reduce by rule number 4. So, this 3 on getting star. So, it will be on state 3 on getting star. So, it will be reducing by T producing F. So, T producing F is rule number 4. So, this should be rule number 4. So, it will reduce by that. So, this F will be going out of the symbol set, and this T will be coming, and the new state will be 0 T. So, 0 T is state number 2. So, this 2 is the new state, and now on 2 star. So, 2 star it says that shift and go to state 7. So, this it has done a shift. So, star is shifted, and this 7 is there on the stack, the state 7 is on the stack. Now, from there it will find that now it is 7 and ID. So, state 7 ID it says shift 5. So, this ID is shifted, and this new state becomes 5. So, that is put into the stack. Now, 5 and plus. So, 5 plus it says that reduce by rule number 6. So, reduce by rule number rule F producing ID. So, it will be taking out ID from the stack, replace it by F, and then F is put into the stack, and then from this 5 is also gone, and from this 7 F. So, 7 F will tell that the go to is go to 10. So, this 10 is put into the stack. So, new state is the state 10. Okay. Now, from state 10 on plus, from state 10 on plus it says reduce by rule number 3. So, reduce by rule number 3 is this one, T producing T star F. So, this T star F will be going out of the stack, and then this state 10 will also be going out. So, the new state is 7, and the left hand side is T. So, 7 T, 7 from actually this state 7 will also go. So, it will be the state new state should be 2. So, where is 2? So, this will be actually when it is popping out when it is taking out this T star f. So, all these states will also go out. So, we have popping out 3 entries from the symbol. So, these 3 states will also go, the 10, 7 and 2 they will go, and 0 on f. So, it will say that from state 0 on t, it will say that it will go to t. So, 0 t. So, this state 2 comes here. Actually, the point is here I am popping out. So, here I have to replace by the right hand side has got T star f. So, 3 symbols. So, 3 symbols are taken to be taken from these symbols, and 3 states are also to be taken from this stack, because for each symbol there is a corresponding state. So, if I am taking out 3 steps 3 symbols from here. So, 3 states are also to be taken out from here. So, this takes it to 0 state it makes state 0 at the top, and from state 0 on getting on the next input t. So, go to 0 t is 2. So, it goes to state 2. So, it is 0, 0 2 and t. So, now from state 2 on plus, state 2 on plus it goes to reduce by rule number 2. So, it will follow rule number 2, that is E producing t. So, it will be removing this symbol from the stack, it will be removing this state from the stack, and now this left hand side is E. So, this is replaced by E, and this 0 E. So, 0 E is 1. So, this state is 1. Now, 1 and plus. So, 1 plus says shift by shift and go to state 6. So, this plus is shifted and it goes to state 6, and now it will be 6 and ID. So, 6 and ID tells it is shift 5. So, it will be shifting. So, it is E plus ID and this is 5, and next it will be 5 and dollar. Okay. So, 5 and dollar says reduce by rule number 6. So, F producing ID. So, this ID goes out, this 5 also goes out. So, F comes in, and 6 F is 6 F is 3. So, accordingly the state becomes 3. Now, 3 and dollar. So, 3 and dollar tells 3 and dollar tells reduce by rule number 4, that is T producing F. So, this F is taken out, T is put into the stack, and now this 3 is also gone. So, 6 and T. So, 6 T is 9. So, it puts the state 9 into the stack, and from 9 dollar. So, 9 dollar it says reduce by rule number 1, that is E producing E plus T. So, it will reduce it by this rule. So, E is so this E plus T is taken out, and so 1 2 3 symbols. So, 1 2 3 states are taken out. Now, 0 and E. So, 0 E says 1. So, it is 1 here, E here, and this is dollar. So, this $1 says accept. So, it will come to the accept state. So, in this particular case, so you can think that as if I have got for understanding this is in a better fashion. So, we can assume that as if we have got a stack of states. So, this is a state stack, and we have got a symbol stack. So, whenever we are popping out something from the symbol stack, we have to pop out equal number of entries from the state stack, and whenever we are doing a push operation or shift operation, the state is shifted here and the symbol is shifted onto this stack. In sometimes, so we can also visualize it like this, that we have got a single stack, where we push both the symbols and stack and the stack states. Okay. Then alternately I have got a symbol. So, this is this may be say ID, and this may be some state number 0, this may be plus, then this may be state number say 2. So, like that. So, I have got alternate between the symbol and the state. So, that can also be done. So, in many books you will find that the convention followed is that way. So, it is a single stack where we have got the alternation of symbols and stack the symbols and states, and so that whenever we are talking about popping out. So, we pop out twice the number size of the right hand side, twice the size of the production. So, like this. So, if you are applying say for example, say this rule T producing T star F. So, in the stack you have a situation where you have got this F, after that some state number, then star, after that some state number, and then T, after that some state number. So, then you are so you have to pop out all these entries from the stack. Okay. So, that way it is 2 into size of the right hand side. So, 2 so total number of entries popped out is 1, 2, 3, 4, 5, 6. So, 6 entries are to be popped out. So, many books you will find that it will say you take out 2 into number of symbols on the right hand side of the production from the stack. So, both are correct. So, either you can consider 2 different stacks, one for state, one for symbol, or you can take it as if there is a single stack where both symbols and stacks are put into symbols and states are put into, and it just whenever we are popping out, we will be taking out twice of that. So, many times we will be following the other convention as well in our later classes for doing this comparison. While we take some examples, maybe we will be doing the other way. So, for constructing SLR parsing table, so first of all we have to construct the collection of LR0 items for G dash, and this state is constructed like this. So, if A producing alpha dot A beta is in a particular item and go to II A is I j, then we have to set action I A to shift j. And now, we have if you have got A producing alpha dot A production, then that is in the set of item in the item II, then one action I A. So, it will be reduced by A producing alpha for all A in the follow of A. So, this basically it is like this, that if you have got some sentential form where in this portion you have got the string alpha, that is you have already seen something which is derivable from alpha. Now, if you are at a state where A producing alpha dot is there, then after this you are expecting to see something which is which can follow the symbol A. So, this part whatever comes, so it is in the follow set of A. So, that is why this rule, that is you look into the follow set of A, and for all those symbols you add the action reduce. And this is the case where it is the whenever we are going to do this particular reduction S dash producing S dot. So, it is going to be the accept state. So, we will discuss about this parsing table construction strategy in detail in the next class.